Opening scene, high energy hook. A massive stadium roof swaying under intense wind pressure, then holding strong. Fast-paced music builds suspense. How can a thin 1 mm membrane resist over 50 tons of wind force? Sounds impossible, right? But this is the power of tensile membranes in modern engineering. In the next 5 minutes, we'll break down how these ultra-lightweight yet incredibly strong materials make it possible. Stay till the end to see how simple pre-stressing transforms this fabric into an indestructible force. Scene 1. Introduction to tensile membranes. Split screen. Animation on the left, traditional concrete and steel structures. On the right, sleek tensile membrane stadiums. Traditional stadium roofs rely on heavy concrete and steel for stability, but tensile membranes offer a futuristic, lightweight alternative. These ultra-strong fabrics are used in stadiums worldwide, creating stunning, durable, and cost-effective roof and facade structures. Scene 2. The 3-step process. Step 1. Advanced materials close-up. Close-up shots of PTFE Teflon-coated fiberglass and PVC-coated polyester membranes being tested in labs. The secret lies in high-performance materials. Tensile membranes are crafted from PTFE-coated fiberglass or PVC-coated polyester, both engineered to withstand extreme weather, UV exposure, and even fire. These materials are produced in long rolls and rigorously tested for durability. Step 2. Precision manufacturing. Animation of membrane rolls being cut and welded into large panels, then stacked for transport. Once selected, these materials are cut and welded into massive membrane panels, precisely shaped according to the stadium's design. But here's the catch: they are made intentionally shorter than required. Sounds strange? You'll see why in Step 3. Step 3. Pre-stressing for ultimate strength. On-site installation of the membrane. Workers stretching it over a steel frame, securing it with aluminum profiles and bolts. Now comes the game-changing step: pre-stressing. On site, these slightly undersized membrane panels are pulled and tensioned to fit the steel framework. This pre-stressing technique transforms the fabric, making it incredibly stiff and strong. Unlike conventional materials that can buckle under pressure, tensile membranes only endure tension, eliminating bending or compression failures. This is why they can withstand hurricane force winds with ease. Scene 3. Real-world application and benefits. A montage of iconic stadiums using tensile membranes: Allianz Arena, Beijing National Stadium, and Sophie Stadium. Tensile membranes are revolutionizing stadium architecture. Their benefits include lightweight design, reducing overall structural load, durability, resisting harsh weather for decades, aesthetic appeal, allowing futuristic and unique designs, sustainability, energy efficient and eco-friendly construction. Closing scene, final takeaway and call to action. A time lapse of a tensile membrane stadium being built from start to finish. From a simple fabric to an engineering marvel, tensile membranes prove that strength isn't just about thickness, it's about design. If you found this breakdown insightful, hit that like button, subscribe for more civil engineering edge, and let us know in the comments which engineering topic you'd like us to cover next. Stay till next video. Visual. The screen fades to black with the channel logo and subscribe now.